Good day, pre-calculus students. This is Mr. Langston, and I'm coming at you right after school. And we just had our lesson today on section 1-7, and I want to again apologize for the notes that you had. I had beautiful notes set up. Everything was lovely. And then for whatever reason, those notes got corrupted, and that's about it. So unfortunately, you ended up with some notes that really weren't like the quality that, I'll say Mr. Langston quality notes. So what I've done is I've pieced together some notes for you today, from the remnants of what I had from that file being corrupted. And we're just going to go forward from there. It's not the best notes, or shall I say it's not as good as the ones I originally had, but we'll just roll. So you need to, in this case, we've got our warm-up that you did this morning, and it's select the correct graph of the given function. Of course, that was multiple choice, but this time we're just going to figure it out and we're going to plot it. So what you need to do is make your t-chart. So you have your x and your y, and you need to plug in values. Now understand, under a square root, I can't get a negative number. I can get 0, but I can't get a negative number. So the smallest number I can plug in for x is -1, because if I plug in -1 plus 1, that becomes 0, and in which case I have my plus 1. So I've got -1 here, and my y value is +1. And if I plug in 0, right here, that's 0 plus 1, which ends up being 1. The whole thing is 1 under the square root. And then I take the square root of 1, gives me 1, so 0 gives me 2. Now, I'm not going to plug in 1. I'm not going to plug in 2, because when I do that, I'm going to get a wonky number under the square root. It's not going to be a perfect square. The next number that's going to give me a perfect square is if I plug in 3. Because when I plug in 3, that's 3 plus 1, 4. Square root of 4 is 2. And then plus 1, I got 3. So this is good enough for me to graph. So I've got -1, -1. I've got 0, 2. And I've got 3, 3. So from here, my graph looks like that. For this one, I need to graph this function. Well, you're going to do your x and your y values as well. Make a t-chart. And I'm going to start plugging in. I'm going to start small. So in this case, I'm going to say, why don't I make x -3? So when I plug in -3, I get -3 quantity squared, which is 9, and 5 minus 9 is, in this case, -4. Now, I can't plug in the value of x being 2, but what I can do is I can go slightly smaller than 2. And the way I represent slightly smaller than 2 is I put a little minus in the upper right corner. And that just tells me slightly smaller than 2. So that will make everything okay. But here's the thing, it is so small, like so small a difference from 2, that it may as well just be the number 2. But it's implied that it's smaller than 2. So for what I'm telling you is I can take and just plug in 2 right here and evaluate it. So 2 squared is 4, and 5 minus 4 is, in this case, 1. Okay? But understand, when I graph it, so I'm going to graph -3, -4. So I've got -3, -4 right there. And now I'm going to go to, when I was talking about 2, I meant -2. Okay? So I'm going to go to -2, and that's going to give me 1 right there. But here's my thing. I've got a less than sign, so I can't be at -2. I can be close to -2, and in fact, I am close to -2 on the left. But I can't be at -2. So I'm going to put that as an open circle, and I understand I've got a parabola, or a part of a parabola. Okay? Now, I can evaluate at -2 this function, because I have a less than or equal. So I'm going to evaluate this. So it's 3 plus x. So 3 plus a negative 2, well, that's going to give me 1. So now I'm over the same exact point. So I can take that closed circle and I can fill it in. I can make it an open circle. And now I'm going to do negative 1. So if I plug in negative 1 into here, I've got 2. So here's negative 1. And now I can't plug in 0, but I can plug in a little bit to the left of 0. So I'm going to put a minus there, which this tells me that I'm really close to 0, but I'm just a little bit to the left. So like if 0's here, I'm just like right there, really crazy close. So if I put 0 minus, it's pretty much as if I plug in 0. So I may as well, let's plug in 0. So I got 3 plus 0, which is 3. And I'm going to plot it, but I'm going to leave it as an open circle. Now, I'm going to right here plug in the bottom one exactly at 0. So if I plug in 0, I get 2. So 0, I get 2. Now that's going to be a closed circle because I'm allowed to plug in 0. So this takes on the value of 0. This doesn't. This is just close to 0. Okay? So and for just good practice, I'll put in another value. I'll put in 1. So 1 squared, that gives me, in this case, the value of 3. Okay, so I've got my graph going like that, and then it does a jump downwards, and then I have my parabola there. So lastly, which graphs represent a function? Well, basically, we're just going to graph it. Okay, so I've got x is less than 1/2, x is greater than or equal to 1/2. So let's start plugging in some numbers. I'm going to plug into my t-chart 0. Oh, actually, sorry. Here's my x, here's my y. I'm going to plug in 0. So when I plug in 0, 0 is less than 1/2, so I'm going to plug it in here. And I'm just going to say my value is 4. And now let's do 1/2, but just a little to the left, where x is less than 1/2. So if I do that, that's going to be 1/8. So 4 1/8. Okay? Now remember, that's an open circle. And now I'm going to plug in exactly 1/2. So if I plug in 1/2 here, I'm going to have 4 minus 2, which is 2. Closed circle. So I'm going to get a jump. I'm going to get a discontinuity. And now I'm going to plug in the value of 1. And if I plug in the value of 1, I'm going to get 4 minus 4, which is equal to, well, in this case, 0. Okay, so I'm going to take and plot it. It's going to be a really kind of wonky plot, but whatever. So at 0, I'm at 4. I'm okay. But then when I get to 1/2, just to the right, left of 1/2, I'm going to be at 4 1/8. So I'm going to go like here. And that's an open circle. So I got a straight line going this way. And then I have 4 minus 4x. So at 1/2, I'm at 2. And it's a closed circle. Did I? Oops. I messed that graph up. 1, 2, 3, 4. I put it on 5. I didn't realize I did that. And then right here is an open circle. So I basically have a graph kind of going like that. And then at 1/2, I'm at 2, closed circle. And at 1, I'm at 0. So now I got one going like that. Okay. So today what we're doing is transformations on functions. Our focus standard is functions and their graphs. What we're doing for our content standard is transformations of functions, and we are going to model graphs with equations of the graphs. And your language objective is you're going to be able to articulate how you model graphs with equations using transformations. So here's the thing with transformations: a vertical shift, it moves the graph up. Okay, if I have a plus a number on the outside, so for instance, if I have x squared plus 1, I'm moving the graph of y equals x squared up by 1. This one moves it down. And the example is x squared minus 1, I move the graph down. If I have a subtraction with the x, so for instance, if I have this, x minus 1 quantity squared, that's a movement to the right of the graph of x squared. And if I have adding next to the x, so if I have x plus 1 paired with the x, quantity squared, that's moving it to the left. So let's actually just get into something. I have y equals x cubed minus 1. So if I want to graph y equals x cubed, here's my traditional graph of y equals x cubed. And it's kind of down here and it's kind of up here. So I've got going like that, and I've got going like that. Okay? Now, this minus 1, I have right there. It means it's a vertical shift down. So I'm going to take the entire graph and I'm going to shift it down by 1. So I have like that. Now, for this one, I've got two shifts going on. I've got this plus 1 on the outside, which basically means go up 1. And I've got the plus 2 on the inside, which means go to the left. So I'm going to go to the left 2, and I'm going to go up 1. So drawing our traditional y equals x cubed. Whoa, kind of went off over here. So let's wrangle that back. That's your traditional y equals x cubed. Now what I'm going to do is do my shifts. So I'm going to shift 2, up 1. Shift 2, up 1. Shift 2, up 1. So my graph is going to look like that. So for a quadratic equation, you have y equals a times x minus h quantity squared plus k. So the a determines whether the graph opens up or down. So if a is negative, it opens down. If a is positive, it opens up. And hk is the vertex. So for instance, we have f of x equals negative 2 x minus times the quantity of x minus 2 quantity squared plus 3. You need to find the vertex. Okay, not a problem. So you find the vertex by h and k. So here is h, here is k. Okay, and it's minus h, which is perfect. It's minus h, so my h is 2, and my k is 3. So my vertex is 2, 3. And what are the shifts of the parabola? Well, I'm taking, and when it's asking what are the shifts, it's asking what this is. okay, all my shifts. So I'm going to go back and I'm going to say, all right, I'm going to go to the right 2, and I'm going to go up 3. And that's my shifts. And incidentally, I open downward. Write the equation for the graph. Okay, so you have y equals a x minus h quantity squared plus k. So my vertex is at 2, 4. So right now I have x minus 2 quantity squared plus 4, and notice I open downward. So I'll put -1. The shape of f of x is equal to x cubed, but shifted 5 units to the left and 2 units up. So I have, I'll call this one g of x, is equal to, so 5 units to the left and 2 units up. So that's +2. And to the left is +5 in the x direction. So what I've got is x plus 5 quantity cubed plus 2. All right, well, that's really about it. I'm sorry, I know I went fast through this. I'm a bit tired. I stayed late. I had to do my notes twice, so it's a little frustrating. So what you're going to do with your discussion topic is with your OBA partner, you're going to discuss how you model transformations of functions using equations. And then in your Haiku webpage, you're going to write a post explaining how you model the graphs of functions using the transformation. So it's in there. I hope everybody has a good time. I hope you understand this. And if you don't, you can always ask me for help. In the meantime, peace, be safe.